Welcome to Special Products in Manufacturing for our 2020 Manufacturing Day event. Come on in!
Engineering. My name is Bo Carroll. I've been with Special Products for a little over 13 years. I first got into manufacturing right out of high school because I wanted to make things with my hands. Since then, I've kind of moved into engineering. I'm currently the engineering manager here at SPM. What I like most about manufacturing is the challenges. We get to work with some really cool softwares. We get to see some really cool designs. We get to work on some really cool projects like the one we see here. This part is part of a 5G antenna for your cell phones. As you can see, this is SolidWorks 3D modeling software. We can explode the part. We can select parts we want to edit. You can see this is a sheet metal part. We can unfold this part right here in SolidWorks. Gives us our flat pattern. And then we can move over to FabriWin. This is one of our 2D softwares that writes code to the machines that we cut these parts out on. I can actually import this part directly out of SolidWorks straight into FabriWin. I can create my sheet layouts for my machines. Make a nice grid here. Get my part spacing however I like it. I can then tool the parts and then post the code out to the machines so that the operators can build these parts. They'll then go to brake press where they'll get bent up, and then we'll be able to go out to assembly and we'll be able to see what our part that we created actually looks like. Thanks for visiting with us here at SPM.
Welcome to the punch department. My name is Jason, and I'm going to show you a little bit about what we do over here. First, I'd like to kind of give some of my background in manufacturing. I started out in manufacturing ever since I was a kid. I've been around this place for a while. Started in the shipping area, did some hardware, and eventually made it over to the punches where we are today. And so we just kind of like to go over what we do over in the punch area. This is the beginning operation and step of the manufacturing process in this building. The material comes in from our outside supplier. We get it here inside and we start to punch and laser cut parts for our customers. And so whenever I say punch, I'm talking about one of these things. This is the tooling used to load into this big old machine in order to make your holes and your rectangles and your squares and your crazy forms and hinges and stuff like that. So what we do is get a punch, and as you can see, that's a round, and it's going to punch a circle into the part. And it mates up with the die, and the material is going to go through and it'll hit, and then you'll get your parts out. And so this step of the process is very important. Like I said, it is the first phase of the manufacturing process. As soon as we get the parts off of these machines, they go further down into the operation, can have a bin put to them, have some hardware added to it, whatever the case may be. But this is a very important step into the process, and it's got to be right here or it won't be right there. So that's what we do.
Hey, my name is Jacob Miller. Today we're in the press brake department of Special Products and Manufacturing. After all of our metals processed through our punch, shake, deburr, laser departments, it comes to the press brake department, and this is where we bend all of our metal. Today we're going to be featuring the Amada EGAR 6013 fully automated electric servo power driven press brake. This is opposed to a normal hydraulic press brake, which allows us better repeatability and more consistency throughout our parts. Some of the highlights, the features on this, are that we do all of our programming offline. We program it in the planning and programming department, so that when it comes to the production floor, the operator simply scans a barcode and the program loads to the machine. The operator will then follow the part through the machine to make sure that we have all of our specs and specification, all of our tolerances, all of our bends and our angles and our dimensions to the blueprint. Once the operator does that, he lets it go. It goes on its own, fully automated, runs 24 hours a day. We have 2 operators that we do on first shift and second shift as well. We have 7-axis potentiometer back gauges that go up, down, left, right, in and out, as well as staggered positioning back gauges for all of our more complicated bends. We also have 3 grippers. We have the micro gripper that allows us to do parts as small as 4.5 inches by 2.3 inches. We have a normal gripper, which allows us to bend parts from 12 to 18 inches. We have an automatic tool changer gripper, which allows the robot to change all of its jobs, all of its tooling in between jobs with no operator needed after the program is scanned. A standard operator in press brake begins to show fatigue after about 20 seconds, which is around 11 parts into a work order. That doesn't sound like much unless you're running a work order of 5,000 pieces. With the robot, we don't show any fatigue after 20 seconds, 20 parts, or 20 hours. So the robot is able to give us repeatability and more consistency throughout our production runs. The best that we've done thus far, we took a 14-hour work order of 750 pieces that ran on a manual press brake. We brought over to the robot, had 7 bends. We knocked it down to a 7-hour run, which allows us to do that in one shift, which opens up more capacity for more parts to be brought into Special Products, more customers, everything down those lines. We do have 4 individual loading stations, which will allow us to load 4 different work orders, 4 different parts. Once the operator checks each one, he can walk away, and the robot can run up to 4 different work orders with no worries. I was actually started at SPM in the assembly department. I put together many different cabinets in the assembly department. I was fortunate enough to make my way over to the press brake department and eventually into automation. I'm responsible for programming all of our automated press brakes, which is 2 EGAR robots and 3 ATCs. What I enjoy most is A, bending metal, just like a regular Superman. And then I would say B, the family and the atmosphere that SPM provides. SPM has a great family atmosphere with fun employees that love being at work every day, love seeing each other every day, and love to give each other a hard time every day. So thank you for your time, and here's the robot.
the Special Products and Manufacturing Quality Department. I'm going to walk you through today what kind of equipment we work with, what we do on a daily basis, and walk you through the ropes of what we do. So to start to work on, basically whenever we first produce a part, it comes out of material. The second thing that happens is it gets loaded onto one of our machines, and we'll laser cut it, punch it, or laser cut combo punch out a part to look like this. Now we design this part on the computer in the flat, and then we send it to our machines to manufacture. Now when we draw it on the computer, we make it perfect. Now what we want to do is we want to make sure that our product is as close to as perfect as it is on the computer once it comes off the machines. So what we'll do is we'll then take those parts once they're produced and throw them on this machine. This machine is a 2D and 3D scanner. What it will do is actually compare the CAD model that we designed to the actual part that was manufactured. Now, this machine will take 40 million measurements in the matter of 0.1 seconds. So that's a lot of dimensions, and it'll take all of those dimensions quicker than any machine manufactured right now to inspect 2D parts. So we're going to kind of walk you through an example of how quick it'll do that inspection and how that process goes. So to start off, what we'll do is we'll come over to our computer, we'll load the software, and then from there what we'll do is we'll select the CAD file that we're going to inspect. Once we select that CAD file that we've designed, what we'll do is we'll complete an inspection. And this is how quick it is. It's almost in the flash of a moment. So what we're going to do is we're going to turn over to this machine right now, and you're going to see some lights come on, but you're going to see how quick it actually inspects these parts. Now what you can see on the computer screen, this is actually an example of what is on the table, exactly number 1, 2, 3, 4, and 5, and that is comparing it to the CAD. What we can actually see right above it is that all of the dimensions, the parts on all of the parts, the dimensions check good. You can see that we had 0 failed dimensions, and we actually checked a total of 200 dimensions on that part, individually per part. So we had a total of 15,753 measurements on that part, and every single one of them passed. So now what we're going to do is we're going to show you kind of an example of what the machine does to tell us which part is which whenever we go over to the machine, so you don't get confused from the computer over to the machine. So as we walk over to the machine, what you'll see is it has a number 1, 2, 3, 4, and 5. So what that tells us is now we can see which dimensions apply to that part and which part is which. So the next thing we're going to do is show you guys an example of how it identifies non-conforming product made for our customers. So we're going to take a small piece of paper. We can actually even make that even smaller. We're going to make it smaller than the tip of my finger. Now what we're going to do is we're going to set it right along the edge of this part here, just right on the edge. And we're going to see if the machine will detect if that part is bad. Because in reality, if that part actually had a burr or a sharp edge there, we'd want the machine to tell us that it was no good. So, for instance, now we're going to re-inspect these 5 parts, and here we go. So you can see the table lights up, and there's a camera above us right now that is taking a picture of this, and it is comparing it to the CAD model for measurements. Next, you'll see a grid kind of go over the parts. It's measuring everything, getting all the dimensions we need to, and now it identifies that one of those parts is no good. As you can see, the part that we put the paper on is lighting up red. As you come over to the screen, what it will actually also do is show us where exactly on that part we had that tape sticking off. Now as you can see, what you're seeing is just that tape or paper that was hanging off, but all of these little tiny itty bitty lines are individual measurements that were taken along the entire edge of that part. Now that is an example of how we will measure and compare our flat pattern scanned parts to what we're manufacturing. What we're going to do now is show you an example of how we measure 3D parts that are formed up, or parts that are made out of a machined part. There's pockets or flanges on it, and we're going to do a quick example for you guys. Alrighty, so what you can see on the screen is a picture of our part. It's actually right over to our right. What you're seeing is actually a light to dark contrast of the part, which is actually going to allow us to pick up on the features on the part when we scan it. So what you're seeing here is exactly what the camera sees. When we move over to our right, what you can see is here is our camera, and then over on the far end of this carbon fiber box, what's over there is also a high definition projector, which is projecting that light onto the part. And we'll also project lines and some other features, as you'll see as we scan the part here in just a minute. I'm going to go back over to the computer, and when I go over here, I'm going to click OK to go ahead and start it, and we're going to start our scan of this part, and then we'll go back over towards the table to watch it scan. So now what you're going to see, we're going to go back over to the computer for just a second, and we're going to see the 3D model that's being rendered of the part that we are scanning. You can see on the screen, this is the part that's on the table, and we're actually rendering our own 3D model that we're going to match and compare to the actual perfect 3D model that we built in SolidWorks or our 3D CAM software, 3D CAD software. Now, when you look at this, you can see a whole lot of little dots on this part, and every single one of those tiny little dots that you're seeing is a measurement that the machine is taking. So this machine is taking over 40 million measurements on this part, and we're going to get an exact surface detection on this part, where it'll show us exactly any defects that are on the part. If there's a dent on the part, if there's a heavy scratch, etc., we're going to see it. As this turns around, you can see we're going to go back to the scanner again, and you'll see that some of the part isn't showing up. That's just because we haven't got it in the picture yet. As the part turns around on the table, we'll get pictures of every single side of this part. So now when we come back over to the screen, what you can see is we took a good amount of pictures of the part, which gave us a lot of data to measure off of. We can always do more pictures, more scans, more rotation to get as much data as we want. Right here what we can see is we got a whole lot of data, and we can measure a good amount of features. We can measure our bend flange lengths, our flange heights of our joggles, overall bend dimensions, bend angles, and etc. So what we'll do is we'll end up taking this 3D model that we just created. It's called a mesh point measurement cloud, and from there what we'll do is we will compare it to our 3D model and see the difference. Outside of that, that's just a brief introduction to our 3D scanning system that we have here at Special Products, and also the 3D/2D version of the machine that we have inside quality. We also have a machine out on the shop floor that the people use during production.
My name is Jeremy Goodgen. I run the robot and program it. It's a robotic welder. We use it to pretty much weld up anything in large quantities, or that it's oversized with a lot of welds. We use this to keep pin. This is what you use to program the robot. You move it with this, you tell it when to weld and when to stop welding, all with this. Right now we're running the pole tops. It's an antenna for 5G, and what we do is we get all the parts, we load it up on the fixture, and then we just hit go once we get it programmed. These are the parts. is all the parts for a 5G. It's the top of an antenna. And then once you get it welded, it ends up looking like this. We're going to let the robot run so you can see what it looks like. Thank you for visiting the weld department. Maybe we'll see you next year.
Hello, welcome to SPM. My name is Joe Carrillo. I'm the supervisor here. I've gotten into the manufacturing. I first started in '95 wet painting. I wasn't a big fan of wet paint. All the fumes I did not like. Then I discovered powder coating, and powder coating is something that's way easier, safer for the environment as well, and for one's safety. We're starting our process. We start off our process here, hanging parts. As soon as we hang parts, they go through our 5-stage wash system. Our first washer is an alkaline, which knocks off any oils or grease off the line. Then it'll go through a rinse, then a phosphate, which is like a soap that washes off any impurities on the parts. And then we have 2 wash systems, rinses. As soon as it'll go through the rinse, it'll go through a dry-off oven at 350 degrees to make sure there's no water, anything that's left on it, it'll burn off before paint process. As soon as it'll go through our dry-off oven, it'll go to the paint booth where parts will get painted. And the powder works with static electricity. These are 2 powders that we have, 2 different colors. We have a yellow and an orange. And all it is just a powder. It's similar to a baby powder, which you can grab and it'll just click away. And the reason and how the parts are stick to the parts are through static electricity. There's a charge on our guns that'll charge the powder, and with that powder is charged, it'll stick to your parts, and it'll work through our conveyor line, and parts are grounded. After the parts are painted, they'll go through the cure oven at 400 degrees. They'll stay in there for about 30 minutes to cure. All it is, it'll harden the paint on the parts. And as soon as they come out of the oven, then that's when they'll unload and they'll get packaged to go to shipping. And thank you for being here, and we really miss you not being here this year, and hopefully we'll get to see you next year.
Thank you for joining us today. We were happy to have you here and show you around our facility and educate you more about what modern manufacturing looks like. If you want to learn more about Special Products in Manufacturing and our career and internship opportunities, you can find all that information at www.spmfg.com. We hope to see you next year.
I do have a counter on the front of the camera, which is unfortunate because now I've seen it and now I know that I'm only 25 seconds into it. That's okay, we've got 30 more seconds to talk.
Hello, welcome to SPM. My name is Joe Carrillo, and I'm the supervisor here at SPM. Stop!
Yay! One more for the blooper reel!
No, I said it twice.
Hi, Armando.
You can see on the screen, we actually need to restart. We need to restart because I didn't show you.
Wow.
Hello and welcome to engineering. No blooper reels, okay?
Oh, I'm making a blooper reel. I already promised Jacob.
Oh, well.